Welcome back, everybody. I know I just posted on Auriga both some objects for beginners, people, introductory objects, so to speak, intermediate objects, and advanced challenging objects. I'm going to break down two of them right here, right now, and we're going to get into them a little bit more in depth. And I think I wanted to share these because I think they're both by each other will show that. And I think if you're a visual observer or an imager, they offer a great opportunity to see what you can see visually and to bring out through an image that you create. So without any further ado, let's get started. Alrighty, so we're going to get started. I'm going to add a couple things into this that I wanted to put into here. So in addition to like I said, discussing Auriga in just a broader sense of introductory objects, intermediate objects, and challenging objects, I wanted to look at two specific of the challenge objects in detail. And I kind of want to go through what my thought process is there. LBN 777 is wide field. It's a dark nebula with reflection in it, no filters necessary. You detect it slowly, and you're looking for the contrast by absence. K21 as a planetary nebula is high magnification. It's an emission nebula. It's narrow band. You're going to use the O3 on this one. You can confirm it quickly. The central star will shine really blue and bright. It'll just look like a star. The filter will bring out the nebulosity around that star. And you can get the contrast there by being persistent in your observation of this object. One teaches patience, the other teaches technique. LBN 777 is going to test your patience. K21 is going to test your technique and help you to develop it better. If you think about it, the other reason I picked this, and this is probably the main reason, is comparing the two LBN 777 to K21. You're seeing two ends of the stellar life cycle here in these two objects. I think that's just wonderful. LBN 77 is cold interstellar dust. It's a star formation region, looks and reflects light. It will probably produce future stars, and it's a wide and diffuse structure. K21, the planetary nebula, is hot ionized gas. It's a stellar death remnant. The star has blown off its outer atmosphere and is now a white dwarf. It emits light because of the heat from the white dwarf lighting up the outer shells that it's dispersed. It's a past star, and it's compact and concentrated. It's eventually going to go into from a white dwarf to a brown dwarf. You won't be able to see it eventually because it will cool, but the gas will not be lit up. And so you're really seeing two things there. LBN 777 shows the raw materials for stars. K21 shows the final return of stellar materials from a star back to space. Think it's that old story of birth, evolution, death, and renewal, and you're going to see it in these two objects. I think that's really cool. So observing LBN 77, the baby eagle nebula or the vulture nebula, if you're chasing dark nebula and faint molecular clouds, LBN 77 is one of those targets that rewards patience and really, really good transparent skies. And I think I really want to put that in here. This isn't a showpiece object. This is not M42. It's not the Orion Nebula. It's not the Crab Nebula. It's not a Messier object, okay? Don't expect wings and feathers or even Thor's helmet to pop out at you. It's not going to happen. You are going to want a 12-inch or larger telescope for this. You don't need a filter with this. If you're going to try a filter, UHC at the most. O3 and H-beta don't help here. This is mostly a reflection in dark nebula. It's not an emission nebula. Eyepieces start at low power, 70 to 100x magnification to frame the surrounding star field, then slowly work up to 120 to 160 magnification for the contrast enhancement on this. This object is more about contrast than magnification. Sky conditions, like I talked about, matter. It's critical. You're going to want to be in Bortle 2 or 3. I'd really recommend a Bortle 2. Excellent transparency. The seeing really doesn't matter on this. You need that excellent to outstanding transparency, a 4 or 5. You only are going to do this on a moonless night. I would do this around new moon. You got to let those eyes fully dark adapt. This one, if you're impatient, it's going to punish you. It's going to frustrate you. Okay? And the Milky Way in Taurus isn't textured and busy looking. LBN 77 probably won't show if you're not seeing some winter structure up there in the Milky Way. What you'll actually see when you actually get there, it appears as a subtle, irregular patch, dark patch that interrupts a faintly luminous background. It's not a pitch black like a Barnard object. It's more like a soft absence of stars. It's almost like a smudge on my sketches. It's a dimming of that Milky Way glow behind it. You're going to need averted vision on this. You're going to need to look off the object. If you may notice curving edges or lopsided bite taking out of the star field with averted vision. It feels more that you're going to detect it than you're going to see it at first. And then the longer you stay on it, the more structure that's going to slowly emerge from this object as it's in there in the eyepiece. I would plan on 20-30 minutes on this object. That's just me. Some people probably 10 minutes and they're good. They're a far better observer than I am. I really have learned patience through my sketching. I really would sit on this. No light. I would not, for that first observation, I'm not even going to sketch it, because the moment I turn even a really dim red light on, I'll probably lose this object. It's going to be one that I'm probably going to have to sketch more from memory and get the star field and then sketch and then dark adapt and go back if I decide to sketch that, which I probably will. It's one of those objects where when you get that aha moment, it's going to come after several minutes. It's not going to come in seconds. If you're impatient, you're not going to get the aha moment. Sorry, but when you get that aha moment, it's going to be awesome. Okay? Some observing technique trips. Sweep the area first to get a mental baseline of the star field. Gently tap the scope. Motion sometimes will help with eye detection. I don't do that a lot anymore, but some people say it does. Averted vision and patience are your two. That's why they're bold. The two things that you need here. Sketching helps a lot here, even rough outlines. Okay, and use the starlight to sketch by. That's probably what I'll do here. Once your brain locks onto the contrast difference, once those rods kick in, it becomes a lot easier to hold this object. The difficulty's high. I'm not going to lie to you. This is a hard object. Visual impact, low to moderate. Observer satisfaction, very high if you're into faint objects. Okay? LBN 77 is a deep sky observer's target. It's an advanced observer's target. It's more about the challenge and the quiet satisfaction that comes from getting it, and it's something that few people are ever going to even try to go and see. And so when you get it, it's very rewarding. It's why I love faint objects. Okay? LBN 77 won't show you like a bright nebula or galaxy, but detecting under dark skies feels like shaking hands with the structure of the Milky Way itself. It's a reminder that space just isn't filled with light. It's shaped by darkness too. Some info on it. You can see I've put info here. It's Lens Bright Nebula 777, Baby Eagle Nebula, or Vulture Head Nebula. It's a dark nebula with reflection components. 500 to 700 light years away. Estimates vary. It's right on that Taurus Auriga border, and it's in the Taurus Auriga molecular complex. So just so you know, it's part of the nearby molecular cloud, like I tried to say. Sorry, I'm just trying to get over this. It's composed of cold interstellar dust and gas. It's not emitting its own light. It's only visible because it blocks the background starlight, that's the dark nebula component, and reflects faint light from nearby stars. That's the reflection nebula component. Scientific importance, it's part of the local interstellar medium. Regions like this are stellar nurseries, or potential future ones. This one is. It helps astronomers to study dust grain composition, light scattering, and reflection nebula in early conditions of star formation. It lies relatively close to Earth on the galactic scale, making it a valuable laboratory for understanding low-mass cloud structures. That's why it's important. Okay, and I think I try to include the info on a lot of these objects just because I think it helps to enhance what you're actually observing if you know a little bit about it. Coming back down at the next one, visually observing planetary nebula K21 at Auriga. It's one of those planetary nebula that doesn't look like much on the chart. And let's just take a minute. I'm going to scroll over to live sky. You can see here, I'll just kind of zoom out. Hopefully you can see this. Here's Elnath at the Horn of Taurus. Here's El Cab in Auriga. You can see that MLB 32, Barnard 28, I believe it is located right there. And K21 is located right here. So you're going to be working this side of Auriga. And you're probably going to want to make sure that you get your Sky Safari, whatever it is you're using, set up. I'd actually, on this one, I'm going to actually go into Sky Tools and print a chart. Once I get the chart, I'll scan it and I'll upload it so it's there. But I want the detailed chart, and I don't want to pull the iPad out. I don't want, even if it's dimmed with covering on it, I just don't want the light on this. It will kill seeing this. I've seen it once. It will kill it. It's been several years. Anyway. So you can see what we're talking about here, and you'll see here's the Milky Way. If you're not seeing just a little hint of structure as you're looking up into the winter Milky Way, as you look up, this is going to be a hard object to see. Okay, so LB111 right here, hard object to see if you're not seeing just a faint hint at your dark side of the winter Milky Way. K21 you'll be able to get. K21 you probably will be able to see. We'll talk about that. Let's go back to that. Okay. It's a K2b1 is a faint compact planetary nebula. It rewards patience, again good skies, and the right filter. If you like hunting subtle targets in Auriga or faint objects, this is on the list. That's why it's on the list. It's in Auriga. It's a fairly busy star field, which makes careful star hopping important. That's why I'll print off and publish and put on here. I'll do that tomorrow when I feel better and I've got some sleep. This is a case where aperture helps. The bigger the aperture, the better the view you're going to see. But also technique matters. That's why this is more of a technique. The other one is going to challenge your patience. This one's going to challenge your techniques. 10 inch or minimum. 14 inches or higher is strongly preferred on this one. If you're visually seeing it, magnification start around 150 magnification, then slowly push it up to 250 to 350. The narrowband UHC is probably a good starting point. O3 will improve the contrast, but as typical of O3, it's going to dim the field. Okay, sorry, I'm just going to pause to take a drink. Try blinking the filter using filtered and unfiltered fields just to confirm that you've actually had it. The white dwarf you'll be able to see. It's going to be bluish, and the filter will bring out the nebulosity around it. And when you blink it, when you take the filter out, that will disappear. Filter will bring back some of that structure. That's the blinking technique. Well, it's a common technique used on planetaries. If you're experienced, you already know about it. High magnification helps to separate the nebula from the surrounding stars and really improves the contrast on this one. What to look for at the eyepiece? It's going to look stellar. Like I told you, it's going to look like a star. That's the trap. Unfiltered, it can pass for a faint star. But once you drop that narrowband or O3 filter in, something interesting happens. The star refuses to fade like the other ones. That's your confirmation. That means you've gotten K21. It's going to appear as a tiny round non-stellar disk, slightly soft edge compared to nearby stars. No obvious color visually, even in large apertures. I've seen a couple of reports online where they said it's a little bluish. You'll have to determine that when you see it. With enough magnification, you may sense that it's not quite focused the same way as surrounding stars, kind of like it has a small thin halo around it. You can blink and compare, center the suspected object, insert the filter, remove it, repeat. If you're getting that kind of out of focus thing, you know you're on it. The object holds while other stars fade, you got it. Let your eyes be fully dark adapted on this again. Use averted vision sparingly. Direct vision often works better on this object. Gently defocus stars to compare their behavior. Don't rush this one. Spend time confirming it. You're going to have patience on this too. Again, sky conditions matter. Dark side, Bortle 1 to 3. Transparency is critical. You're going to want a 4, probably a 5 on transparency on this. If you're in haze or light polluted, you're not going to get it. Okay, so watch that. Okay, make sure you're on a moonless night. Steady seeing to allow the higher magnification can also improve it. It benefits from contrast more than raw light gathering on this one. K21 won't. It's not going to wow you. It's not going to be the Eskimo or NGC 1535 Cleopatra's Eye. It's a deeply satisfying object to log though, because it is faint. Catching it means your star hopping was solid, your filter use was on point, and your observing skills are sharp. It's a good test of your observing technique. Often those are sometimes, for me, the most rewarding ones to get. Okay, you can see the info here. If you want it, it will be on the post on my page, on my Patreon page. And just so you know, it's a late evolutionary stage of low to intermediate mass stars. It's why do astronomers look at these faint planetaries, nebulae, and stellar mass loss, trace chemical enrichment to the galaxy, and measure how stars recycle material back to the interstellar medium. They're a major source of elements like carbon, nitrogen, and oxygen. So just realize you're not just ticking off faint objects when you look at these two objects. You're witnessing stellar recycling in action, like I talked about at the beginning. Dust clouds are collapsing into stars, stars evolve, and eventually return their material back to the galaxy as they die. When the process begins anew. Like I said earlier, it's the age-old story of birth, evolution, death, and renewal. See, that's the real story when you get in behind the objects you're observing. That's the real story here. That's what makes this hobby exciting to me, is you're expanding your own knowledge, you're learning more about these objects and why they're important and what they're showing and why astronomers are looking at them, and you get the challenge of seeing if you can see it for yourself. So good luck to you. Hope you take up the challenge. If you do, I'd love to see how it works in your report. Leave a comment or a link in the comments, and so we can see that. And have a wonderful night. Hope this helps a little bit. See you later.